Okay, so again, it is called a difference of squares, and the pattern that we use is listed here. First of all, it's going to look like this. Two terms, okay, so a binomial. Both have to be perfect squares, and it has to be subtracted in order to use our pattern. And if they are both perfect squares and subtracted, then we can use this pattern here, which is basically you take the square root of whatever term is listed first, and you put it in front of both of your parentheses. Then you take the square root of whatever term is listed second, and you put it in the back of both parentheses, and you do 1 plus and 1 minus. Order of it doesn't matter as long as you have 1 plus, 1 minus, and the square root of each term. The key thing we need to remember, and this always messes people up, if I have two perfect squares that are being added together, the sum of perfect squares, that is always prime. You can never, ever, ever factor if it's two perfect squares being added together. We still want to look for a GCF when we factor, no matter what kind of factoring we're doing. So we're always going to ask ourselves, even with just two terms, are they both perfect squares? I'm sorry, scratch that. Is there a GCF? And then are they both perfect squares? Okay. So we are going to start with a couple of relatively easy ones. Not that they get too terrible hard. Sometimes these can factor further more than once, and we'll get to an example like that in a few minutes. But we're going to start with the first one, x squared minus 25. The very first thing we want to ask ourselves, do we have a GCF? Do x squared and 25 have something in common? No. Okay. Second thing we need to notice, okay, especially when we get to putting all of this together in a couple of days, how many terms does it have? It has 2, and then that helps us to decide are we going to use squares or cubes? Are the two terms both perfect squares or both perfect cubes? Both perfect squares. So we are going to use the difference of squares pattern. Again, I'm just going to set up my two parentheses. I want to take the square root of the first term. What is the square root of x squared? How do you break that down into two equal things? X and x. So that's going to go in the front of both of our parentheses. And then we're going to take the square root of the second term. What's the square root of 25? If you're not sure, this list helps. Find 25, go over to your root. That tells you what the square root is. The square root of 25 is 5. And then as far as my signs are concerned, I just do one of each. 1 plus, 1 minus, but the order does not matter. I tend to usually put my plus first. That's just out of habit. It doesn't mean that it's wrong if you put the minus and then the plus. And then the only other thing we want to do is we want to look at both of our parentheses and make sure we cannot factor any further. Each parenthesis has 2 terms. The only way you can factor with 2 terms is, first of all, a GCF. And then secondly, if they're squares or cube. Are x and 5 both perfect squares or cubes? No, they're not. So that means I am done with this one. That's all I have to do. Bless you. Everybody okay with that? All right. Let's take a look then at number 2. Again, the very first question we want to ask ourselves, do we have a GCF? Do 9x squared and 16 have anything in common? No, they do not. 2 terms. Are they both perfect squares? Are 9 and 25 both on my list? They are. Okay, so we're going to set up our 2 parentheses. We're going to start by taking the square root of 9x squared. What's the square root of 9x squared? 3x, yep. So that goes in the front of both of my parentheses. And then we take the square root of the last term. What's the square root of 16? 4. And then we do 1 plus, and we do 1 minus. And we just want to check to see, can either one of those break down any further? Are 3 and 4 both perfect squares or cubes? No, 4 is, but 3 is not. Therefore, that is all I can do for that one. As long as you recognize squares and you remember square root of the first term, square root of the last term, 1 plus, 1 minus, that's about as hard as these get. Is everybody okay with those? Okay. Try 3. x squared plus 36. First things first, do I have a GCF? Are both terms perfect squares? It's the sum of squares. It's got two perfect squares that are being added. You remember the first page I said, and I highlighted it in blue. This is what we miss all the time. Yes, they are both perfect squares, but they are not being subtracted. You can only factor perfect squares if they are being subtracted. Since this is addition, what did we say? The sum of squares is always prime, and let me show you why. Okay. If I were to take, some people say, oh, well, you can break it down and it'll be two pluses, right? Well, let's look at this. If I were to multiply that back out, it's a plus, not the x. Multiply those two, and multiply those two. What happens when I combine two positive sixes? What do they give me? They give me 12. So do you see how I don't end up with what I started with? And then the other option is people do the same thing, but they change the signs, and they say, well, I'm going to do a minus and a minus. Okay, again, same thing happens here. These just turn into both negatives, which means it still doesn't get rid of that middle term. Okay, so you cannot factor a sum of squares. Always has to be a difference. That's why it's called the difference of squares. Now, 4 can be a little tricky because we get in the habit of just doing square root, and moving on. 4 and 64 are both on my list of squares, aren't they? However, what is the very first question we're supposed to ask? Do we have a GCF? Do 4 and 64 have something in common? Yes, they do. They share a 4, right? So we have to pull that 4 out first. Well, this is not writing properly. And once I pull that 4 out, look at what I have left. The x squared minus 16. Are those both perfect squares? They are. So we can break those down further. We're not going to lose that 4. We're going to break down what is the square root of x squared. X, and the square root of 16 is 4. And then we just do 1 plus and 1 minus. Let me show you what happens if you were to factor it as it is without pulling out your GCF. The square root of 4x squared is 2x. The square root of 64 is 8. 1 plus and 1 minus. But if you remember, we talked about you cannot have terms in the same parentheses that have something in common. Do you notice that those are both divisible by 2? So that lets me know that that's not the correct answer because I'm never allowed to have terms in the same parentheses that have something in common. So just make sure you get in the habit of looking for your GCF first. Is everybody okay with that? Hold on. Okay. Try both of the, well, try 5, and then we'll do 6 together, and then I need to, there's one I didn't add to the notes that I need to show you. So try the number 5, 49x squared minus 100. If you think you can do 6, you can go ahead and try it. 6 is just like the next level up because and again, if you're not really familiar with your squares, that's why we made the list. Just look at your list of squares. Now, that's not all the perfect squares. There could be numbers bigger than 100 that are perfect squares. We just made a list of the first 10. Do 49x squared and 100 have anything in common? No. Okay. Are they both perfect squares? Yes. Are they being subtracted? Yes. So we can factor them using the difference of squares pattern. What is the square root of 49x squared? 7x. That goes in the front. And the square root of 100 is 10. And then we just do 1 plus, and we do 1 minus. 7 and 10 are not both perfect squares, so we cannot go any further. Is everybody okay with that one? Okay. All right, now 6. I've got x to the 4th minus 81. First question, do I have anything in common with those two terms? Nope. All right. Are they both perfect squares? With variables, if you aren't sure about whether it's a perfect square or not, if the exponent is even, then yes, it's a perfect square. That means it can be split into two groups evenly, okay? So let's think about this. If I wanted to take x to the 4th and I want to split it evenly twice, it's going to be x what each time? X squared, okay? And then what is the square root of 81? 9. And then we do 1 plus and we do 1 minus. If we had this question on our test next week and you left your answer like that, you would lose points because it's not finished. Okay. Looking in both of your parentheses, x squared and 9 is what I have in both of my parentheses. Those are still both perfect squares, aren't they? Okay. Here's the key. Which one cannot be broken down any further? The x squared plus 9, okay, because the sum of squares cannot go any further. What I'm going to do is I'm going to bring that one down. Okay, it can't be factored because they are both perfect squares and they are being added. However, x squared minus 9 can break down a little further. What is the square root of x squared? X. And what is the square root of 9? 3. And then we do 1 plus, and we do 1 minus. And every year I give a type of question like this. Some people leave it as x squared plus 9 and x squared minus 9, so I have to take points off because it's not finished. And then some people break both of them down, okay? Just remember, if it's two perfect squares and they are being added together, you cannot break those down any further, so just be very careful with that. Now, one that I did not put in the notes that I need to show you, okay, just a little extra one. If I have something that looks like this, 4 minus x squared, do they have anything in common? Are they both perfect squares? Are they being subtracted? Yes. Okay. For some reason, anytime I give a problem like this, people think they can just rearrange the numbers. You cannot rearrange with subtraction because it means a whole different thing. We factor it exactly the same. It just looks odd because our variable is second. We still take the square root of the first term. What's the square root of 4? 2. That goes in the front of my parentheses. Then we take the square root of the second term. What's the square root of x squared? X. And we still do 1 plus and 1 minus, okay? Don't let the order, because you're used to the variables being first, don't ever switch it around. Think about it like this. Let's say if x were equal to 1, okay? People always want to switch it around. If I were to plug a 1 in here, you don't need to write this down, I just want to show you. What's 1 squared? Okay, that gives me 3, right? If I were to plug it in here, whoops, what kind of 3 does that give me? Negative 3. Those are not the same, are they? Okay, so do not switch them around if the variable's second. Just leave it in that order. Square root of the first term goes in the front, square root of the second term goes in the back. So that's how you would leave that answer. So we feel pretty good with squares? Okay. Now cubes. We can factor both a sum and a difference of cubes, and there is a pattern that we will need to memorize. I'll give you just a couple of minutes to write it down. Okay, here's your pattern. You'll notice it doesn't have any signs. We'll talk about those in just a second. We are also going to use this word to help us with our signs. Okay, again, it's a sum of cubes and a difference of cubes. Two perfect cubes, either added or subtracted, can be factored. You just have to memorize that little pattern that I highlighted in yellow. In your first parenthesis, it is A and B. The second parenthesis is A squared, and then A times B, and then B squared. And just realize that I left spaces for our signs, and we will talk about how to fill in those signs using the word soap in just a minute. Okay, first parenthesis, A and B. Where do we get A and B from? It is the cubed root of A to the third and B to the third. Again, if you're not sure the cube roots, this chart can help. If I had like 27, the cube root of 27, I would just scroll all the way over to my roots, and that would be 3. Okay. So, in the first parenthesis, we have A and B. Okay, we're going to fill in a sign in just a minute. The second parenthesis, we have A squared, A times B and B squared. The word soap helps us fill in your signs, and you have 3 positions for your signs. I'm going to circle those. You're going to put a sign here, and a sign here. What I mean by a sign is a plus or minus sign. Soap means your first sign, the one that goes in between A and B in that first parenthesis, is going to be the same as whatever it is in your problem. If it's a plus, the first sign is a plus. If it's a minus, the first sign is a minus. Okay, so this is our S. That means it's the same as the problem. Then the second sign is going to be the opposite of the sign in your problem. Whoops. And then the A and the P refer to your third sign, which is always, what do you think? Positive. Okay, first sign, second sign, these together go for my third sign. Okay, so soap, same, opposite, always positive. Stop. Sorry, keeps moving when I'm trying to write. Is everybody good so far? All right, so let's take a look. We're going to start with x to the third minus 8. Again, the very first thing that we are going to look for is a GCF. Do x to the third and 8 have anything in common? No. Okay. And then we need to ask ourselves, are they squares or are they cubes? Okay, well, the variables give you a hint. 3 is not even, so it's not a square, right? So that gives me a hint it's a cube. Is 8 on my cube list? It is. Okay. So this is the way I do it. What I like to do first is I like to figure out what A and B are. What is the cubed root of the first term? What is the cubed root of the second term? And then I can just fill those into my pattern. And I usually just kind of write it above. A is going to be whatever the cubed root of x to the third is. If I split x to the third into 3 equal groups, how many is in each one? 1. So A is going to be x to the first, or just x. And then B is whatever the cube root of 8 is. If I'm not sure, look at my list. I go to my cube 8 and I scroll all the way over to my roots. And what is the cube root of 8? 2. And then what I do is I fill in my A's and B's, and my A squared is A times B and B squared. And then I'll go back and do my signs. So in my first parenthesis, it is my A term first, which we said was x. My B term second, which we said was 2. And then I have my trinomial. The first one is A squared. So if I square x, I get x squared. That middle term is my A times my B. What is x times 2? 2x. That goes in the middle. And then my last term is B squared. What is 2 squared? 4. Okay, so I filled in the A's and the B's, the A squared is A times B and B squared. Now I can go back and use the word SOAP to help me fill in my signs. The first sign is the same as what's in the problem. What's in the problem? A minus. So we're going to put a minus in that first parenthesis. The second sign is the opposite of that. What's the opposite of a minus? Plus. Whoops. And then the third sign is always positive. Sometimes when you're factoring, this binomial can break down a little further. It might still be perfect squares or perfect cubes. However, this trinomial will never be able to factor, okay? Okay, that trinomial will never be able to factor any further. The binomial, the two terms may, if they're both perfect squares or both perfect cubes still. But that trinomial will never break down any further, so there's no need to even waste your time trying. Okay, do x and 2 have anything in common or both perfect squares or cubes? So that is exactly how I'm going to leave my answer. Okay, go ahead and try 8 if you haven't already. Figure out, first of all, what your a and your b are. What's the cube root of the first term? What's the cube root of the second term? Then you can fill those into your pattern. And you fill in the first parenthesis, second parenthesis, a squared, a times b, and b squared. When we fill in our sign for the SOAP, first sign is the same, second sign is the opposite, third sign is always positive. X cubed and 27 have anything in common? Okay. Then I need to say, are they both perfect squares or both perfect cubes? Cubes. Okay. This is kind of the thought process we'll get through in a couple of days when we put all this factored stuff together. All right. So since they're both perfect cubes, I want to figure out what my a and my b are. What is the cube root of a to the third? I mean x to the third. X and the cube root of 27 is 3. First term is just those two. Second parenthesis is going to be my a squared, my a times b, and my b squared. And then I fill in my signs. Same, opposite, always positive. So what do I go first? Plus and then a, minus and then a, plus. The only thing I want to check for is that first parenthesis. Does x plus 3 break down any further? Squares or cubes? No. So as long as you can identify your numbers, squares and cubes, and as long as you can remember your patterns, these aren't really hard. It's just a matter of plugging some numbers in. Is everybody comfortable with those? All right. Let's try these two. These will be our last two. Yep. Those are our last two. I want you to try mine, but be careful because this one actually has a number in front of our x to the third. So when we figure out our cube root, we need the cube root of 64 and the x to the third together. Because 64 and 27 don't have anything in common. What is the cubed root of 64x to the third? 4x. Okay, so my a is going to be 4x. And the cubed root of 27 is 3. Be very careful when we're plugging these in, especially into that second parenthesis. The first parenthesis, it is just going to be the 4x and the 3. But in the second parenthesis, if I square 4x, this is where a mistake is made. A lot of times people just put 4x squared. I've got to square the whole thing. 4x times 4x is not 4x squared. It is 16x squared, okay? So when you're doing that first term, you have to square the whole thing. Square the 4 and the x. If you think about this, multiplying these things back out, in order for me to get a 64x to the third, I have to get that from those two. If I don't have the 16, that doesn't give me the 64 that I need. Okay, so just be very careful. If your a has a number in front of it, it also gets squared. And then I'm going to multiply 4x times 3, which gives me 12x. All right, and then I'm going to square 3, which gives me 9. And then I can fill in my signs. Same, opposite, always positive. The only other thing I would check is that 4x plus 3. Does it break down any further? No. I would like for you to try 10, but remember what's the very first thing we ask ourselves? Yes, do we have a GCF? Because 4 is a square, but my variable is an x to the third, which is not a square. So we might think we would use difference of squares here. However, they're not both perfect squares. The number part is, but the variable is not. So we just have to keep in mind that we always look for a GCF first. Once you pull that out, then you can pick your pull that out. Very first thing we need to do is pull out our GCF. What does 4x to the third and 4 have in common? All right, so we're going to pull that 4 out. And that leaves me with 1x to the third minus 1, right? 1 is always a perfect whatever root you're talking about. Square root, cube root, fourth root, fifth root. It doesn't matter because 1 times 1 times 1 is always just 1. The key here to knowing which one is these are going to be is your variable. Is x to the third a perfect square or a perfect cube? It's a perfect cube, right? So our a term would be whatever the cube root of x to the third is, which is x. Our b is going to be the cube root of 1. What's the cube root of 1? 1. We're going to do our pattern. The only difference here is that 4 is going to stay in the front. My first parenthesis is my a and my b. And then my second one is my a squared. A times b and b squared. Okay, and yes, you can put a 1 in front of all those x's. It is exactly the same. And then as far as my signs go, the first sign is going to be the same. Second sign is opposite. The third sign is always positive. And that's how that one looks. The only difference is we had to pull the GCF out first.